This video is going to explain how to convert from a logarithmic form to an exponential form or vice versa. Okay, I wrote the property for this section here. This is noteworthy. Okay, so converting between log form and exponential form. Okay, I can, as you can tell with my arrows here, I can go back and forth. I can go from log form to exponential and exponential form to log form. Okay, and this is the property here that we follow. If we just take a look at it, if I'm given a logarithmic function like I have here, what I'm going to do to change it to an exponential function, I'm going to grab my base, right, of the log, which will now be my base, right, my base for this exponential equation. Okay, so again, I grab my logarithmic base and I raise it to the power of y. So whatever you're taking the log of is equal to, that will be your exponent. Okay, and then here we're taking the log of x, so that will be equal to this exponent. So in other words, log functions are inverses of exponential functions. I said in class they go hand in hand. Actually, if you take a look at it, logarithmic functions are exponents, okay? Inverses of each other. So I have three examples here, and the instructions are to rewrite or let's say as or somewhere along the lines, right? I may say rewrite as, or rewrite the logarithmic function into an exponential function, or form, right? They use form a lot. Okay, so this is a logarithmic, so I'm going to try to change it into an exponential form. This is, again, we can distinguish this as an exponential function because I have a variable as an exponent and there's no log. Okay, so I'm going to want to convert this one to a log form. Same here, exponential, so I'm going to want to convert it to a log form. Okay, so being able to convert here is going to help us once we start solving more advanced logarithmic and exponential functions. Okay, so I have this, and all I have to do is change its form, right? So I have a logarithmic form, so exponential form. Again, if I follow this, grab my base, and I make it the base for this exponential function, then whatever it's equal to will be my exponent. So in this case, the log base 2 of 128 is equal to x, so the x will be my exponent there. And then whatever I'm taking the log of, we're going to set it equal to that. And that is it. Okay. You can follow this if you look at this little section there. Continuing here, this is exponential again. We're going to change it to a log form. So we're going to go backwards. Whatever my base is going to be my log base. So if this is e, the constant e, I'm going to have a natural log. Remember that the natural log, or ln has a base of e. Okay, so ln, and I don't have to write the base because we already know that the natural log has a base of e. Okay, we set it equal, so x, right? I have this one. X is 96, so that's what we're gonna take the log of. So I'm gonna put 96 here and set it equal to whatever my exponent is. In this case, x plus 2. And that is it. It's that simple. But it requires us to know this conversion. Now, I wrote this one last minute because I wanted to stress this 2 here, okay? Now, it could be a 2, it could be any other number, right? But this 2 is being multiplied to this constant here, e. It's being multiplied, okay? Before I can change it into its other form, okay? Before I can do that, I have to move that 2. Okay, so the base must be alone. Okay, my base is not alone here. It's got a 2 that is being multiplied to it. Okay, so watch out for that. Be careful. So because they're multiplying, I can divide by 2 on both sides. And then 2 divided by 2 is 1. And then 36 divided by 2 is 18. So this would be 1, and I'm just left with e raised to the power of 3x. Okay, once I have my base alone, nothing being multiplied to it or divided by, I can now change it to a logarithmic form. So again, my base is e, so I know that will be the natural log. Okay, and I'm gonna take the natural log of what it's equal to, so 18. And I'm gonna set it equal to my exponent. And we are done.